Hello and welcome. My name is Sydney Howlett, and I'm going to be guiding you through today's session, Closing the Loop on Plastic. I'm tuning in today from land covered by the Haldeman Treaty. I am so grateful to live and work on these traditional lands that were granted to the Haudenosaunee of the Six Nations of the Grand River. I'm within the traditional territories of the Anishinaabe, Neutral, and Haudenosaunee people who have cared for these lands for generations. I'm a former teacher and the engagement manager for Green Learning. If you don't already know, Green Learning is a national not-for-profit organization that creates free online educational resources about climate change, energy, and the green economy. Our mission is to engage, empower, and inspire students like yourselves to create a better world. So what are we here to learn about today? Well, by the end of this session, I hope that you are able to compare the environmental and economic benefits of a circular economy to a linear economy, list 3 ways technologies are supporting the transition to a circular economy for plastics, and identify personal actions you can take to support a circular economy and reduce plastic waste. Let's start off with what Canada looks like today. Now, when I say economy, I'm referring to the wealth and resources of our country, especially in terms of how we produce and consume goods. Canada has what we call a linear economy of goods. As you can see, that means that materials are extracted from the natural environment, produced into a usable good, distributed around the country, used by us, the consumers, and when we're done with it, we dispose of it and it becomes waste. You might be thinking, but wait, not everything goes to a landfill or becomes waste, which is why our linear economy looks more like this. There are several opportunities throughout the process where goods can be put back into the economy. By making a high-quality good, we're able to extend the lifetime of a product. Through consignment and online marketplaces, we can pass our goods on to be reused by someone else. We can also manufacture or refurbish old goods, such as cell phones and laptops. And most commonly of all, we can recycle goods. While this is all great, majority of our products still end up in landfills as waste. So what's the alternative to our current linear economic model? We're going to watch a short video to find out.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food, energy is provided by the sun, things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components, and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
To summarize, we currently operate on a linear economic model, where products are designed to eventually end up as waste in landfills. We want to transition to a circular economic model, where no waste is being produced. Anything we create stays in the economy, can be repurposed, and completely recycled. One area where a circular economic model is particularly important is plastic waste. In recent years, plastic has been invading our environment in the worst ways. Before we talk about some of the solutions to plastic waste in our environment, we're going to play a game to learn a little bit more about what the problem is. Educators, please open the Kahoot link sent to you with the materials for this workshop or found in the description. Students, with your devices, head over to kahoot.it and type in the game pin to play. Once you finish playing and exploring the slides, please come back and hit play so we can continue on with this workshop. Welcome back. How did it go? Did you learn something new about plastic waste? While the numbers aren't great, there are many technological and environmental solutions on the horizon to address this problem of plastic waste. We're going to look at 3 different ways to address this problem: reduce, reuse, and recycle. Now, some of you might think that these, known as the 3 R's, are equally valuable. They aren't. Our number 1 goal is to reduce the amount of plastic being produced. This is for a number of reasons, including the high pollution caused from its creation through crude oil, and the fact that it degrades into microplastics in the environment. One way we can reduce the amount of plastic being produced is by replacing it with more sustainable options. For example, switching out your plastic straw for a stainless steel one. One really innovative example is actually using nature as our inspiration. Scientists are able to extract the chitin from shrimp and manufacture it into a biodegradable plastic-like material. This material can be used for traditionally single-use plastic items such as cups or food packaging. The next step is to reduce what we cannot reuse. There are many ways we can take old plastics and recreate them into something new. For example, Collingwood School in Alberta made it their mission to collect all the non-recyclable plastics in their school for an entire year. They stuffed the non-recyclable plastic into 2-liter pop bottles and created what is known as an eco-brick. These bricks are more durable than stone bricks and are great for building everything from furniture to homes. Collingwood School built the couch you see here, along with a table and chair for their kindergarten classroom. They continue to collect the plastic and are working on an igloo for their outdoor classroom. The final stage of addressing the plastic problem is recycling. There are 2 main ways plastics can be recycled. The first is recycling plastics into brand new goods. Plastic is collected from homes, schools, and businesses and transported to a processing facility. It is then sorted and cleaned before being heated to the point of melting. It's formed into pellets and sent off to be manufactured into something brand new. For example, Green Toys takes plastic milk containers and recycles them into new sustainable children's toys. Rothy's uses different types of plastics and recycles them into women's shoes and handbags. The other way to recycle plastics, particularly plastics that are contaminated or have lost their structural integrity, is to convert them into energy. The technique of converting plastic waste into energy is known as pyrolysis. Pyro means heat and lysis means break down. So pyrolysis is the process of breaking down plastic waste by exposing it to heat. So what does this process look like?
many steps involved in plastic pyrolysis process, but we are simply going to see 5 steps. Waste plastic to pre-treatment process, shredder, pyrolysis, condensation, refining. Waste plastic is first sent into a pre-treatment process that removes any foreign matter, then sent into a plastic shredder. Plastic shredder is a machine used to cut plastic into smaller pieces. The smaller pieces of plastic then sent into a densifier that compresses the smaller plastic pieces into dense material to facilitate easier storage or handling. Then they are sent into a chamber where the pyrolysis of plastics takes place. The plastic is heated up to 450 degrees centigrade in the presence of catalyst and in the absence of oxygen. The plastic is slowly melts and converted into gaseous state. Then the gas is sent into a condenser. Then the condensation takes place. Condensation means conversion of a vapor or gas to a liquid. Then that is sent into a oil refinery chamber. And finally, plastic waste is refined into approximately 80% oil, 15% gas and 5% carbon black or ash. And this oil is used as a heating material and sell it to cement, glass, ceramic, electric power factories, etc. And also used in heavy oil generator for electricity generation. And it is deprocessed into diesel oil with a distillation plant. The final oil can be used in trucks, tractors, etc. 15% gas, which is recycled into furnace to heat the reactor instead of using coal, wood, oil, etc. And the remaining carbon black or ash is used as a slag for construction.
You know what the problem is and some of the solutions to addressing the problem of plastic waste in the environment. You can add to these growing solutions. What business, product, or campaign would you design to reduce plastic waste? Register for Green Learning's Eco360 Challenge and let us know. Pitch a short video of your innovative idea to reduce plastic waste and you could win a grand prize of up to $1,000. The winning submission from last year proposed a recycling system that would collect the discarded plastic waste from the school's 3D printer and convert it into usable pellets to put back into the 3D printers. What will you come up with? Pause this video now and using the Innovation Plan handout, propose a solution for plastic waste in our environment. Thank you so much for joining me today for Closing the Loop on Plastic. My name is Sydney Howlett, and educators can email me with questions and feedback at sydney@greenlearning.ca. I look forward to hearing your creative solutions to the plastic problem.